Yo, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And this is the part 2 of quick sort sorting algorithm where we are gonna write a code in C++ program to implement the quick sort sorting algorithm. Now before we start off, if you don't know what quick sort is, how it works behind the scenes, and if you are doubtful about the entire working, please watch the part 1 of quick sort because that's where we've discussed the entire algorithm, we've dry run that algorithm, we've taken diagrammatic representation and we saw step by step what happens in the algorithm. So part 1 is more important if you don't really understand quick sort. Part 2, that is this part, is just the implementation of that algorithm, so converting that algorithm into C++ code. So I'll link that video, in fact I'll link the entire DSA course, the entire playlist. There are a lot of video tutorials in this playlist, do check it out. And with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. So we are gonna write C++ programming, but the algorithm is pretty much the same, so you can use any other general purpose programming language like Java, JavaScript, Python, whatever you have. Just the syntax is gonna be different, but the logic is gonna be the same. So I'll put the algorithm on the right. You can see the quicksort algorithm as well as the partition function algorithm which is used in the quicksort algorithm on the right hand side. And this is what we saw in the part 1. So we are simply gonna convert this in C++ code and I'll explain to you at every step, but as I mentioned, if you want in-depth what happens behind the scenes, watch the part 1. So let's quickly get started. And as you can see, I've already typed a little bit of C++ code. You can open up your C++ ID or whichever ID you are using and type in this boilerplate, that is the structure of C++ program. So in the int main, let's get started with the coding. The first thing is we will create a size variable and an array and then take the size of the array from the user. Now this is possible in the later versions of C++, that is dynamically taking the size of the array. Otherwise, if you're using Turbo C++, the array size has to be predefined and it is not something that you can do at runtime. So I'm gonna write int size equals to 0 and then I'm gonna say enter the size of the array. Then I'm gonna say C in size. So take in the size. This is how you actually take in input and this is how you print the output. I hope you know basic C++ syntax. I have a complete C++ tutorials course also. And then I'm gonna create an array saying int myArray with that size that you've entered. Okay, so this is very basic. The next thing that I'm gonna do is I'm gonna say cout enter. Then I'm gonna print the size that you've entered. So the way it is gonna be printed is enter n integers in any order. So this size is gonna be the size that you enter. So if you enter 5, so it will be enter 5 integers in any order. Next thing I'm going to do is I'm going to say for int I equals to 0, I less than the size I plus plus. So this is just running the for loop on this array and then I'm going to take input of every element of the array. Okay, so this is again basic. I know I'm literally copy pasting this code because this is simple. You can pause the screen. I'm obviously going to be sharing this entire code on our official website, but I would request you guys to type it for the first time if you're an absolute beginner. But if you want, you can refer this code, link in the video description. And yeah, so now next thing is this is where we take the input from the user. We've stored it in the myArray array. After this, I'm gonna say before sorting, and then again I'm gonna use this same for loop to print out the array elements which are not yet sorted. Okay. So again the same for loop I equals to 0, I less than the size of the array I plus plus, and then I'm gonna say cout myArray of I. And then concatenate a little bit of space between the elements that are printed. After that I'm going to say cout endl so that we come on the next line. Now after this is where we call our quicksort function. Now obviously we have to create this user defined function over here on the top before the int main. But right now I'm just writing it as it is. If you see the diagram or if you see the algorithm on the right hand side, the quicksort function takes the array. It takes the start index s and it takes the end index. Now in the array, if the size is 5, the start index is 0 and end index is 4 and not 5, right? The indexes start from 0, so it should be 1 less than the size. So I'm passing our array myArray like this. You don't have to use square brackets when you pass the array into a function. The next thing is start index, which is 0 obviously, and the end index is going to be size minus 1. Hence this is the code that you have to type. Okay. Now after this, I'm again gonna say cout after sorting, and again use the same for loop, but this time it is gonna be sorted because quick sort is called over here. So let me just comment this out. Quick sort called here in the main function. Okay. Or I'll just say quick sort called. Okay. Now we have to create this quicksort function as well as the partition function which is there inside the quicksort function. So this was all about the main function. Okay, so let's just save this. I'm gonna say quick underscore sort underscore algorithm. Okay, hit execute, compile and run. Let's see if this works. Okay, yeah, we're getting an error because we still have to create this function. Obviously, I'm just gonna comment this line for now. And let's see if everything else works. Everything else should work basically. So you have to say enter size of the array. I'll say 5. Enter 5 integers. I'm going to say 5, 6, 4, 3, 2. If I hit enter, it is saying before sorting 5, 6, 4, 3, 2. After sorting 5, 6, 4, 3, 2. Now obviously we are not yet sorting it. I just wanted to check if everything is working. So once we apply the quick sort, once we create this function, the array obviously will be sorted. Okay, so let's come at the top over here. Let's create this function. I'm gonna say void quicksort. The first parameter of the quicksort in the algorithm also you can see is an integer array. You can use float array, you can use double array also, but right now the data type that we are using is integer. The second parameter is the start index denoted by s. So I'm gonna say int s. And the third parameter is obviously the end index denoted by e. Okay, this is basic. So the very first step in the quicksort function, as you can see, is first we have to check if s is less than e. This is the very basic step, basic checking, without which we will go into an infinite recursion, because quicksort is recursive and uses the concept of divide and conquer. We've talked about it previously. So this condition basically checks if the start index is less than end index. So this condition basically means that this quicksort will call itself recursively till we have more than one element in the subarray. Because when the start index and end index will be equal, it will mean that there is only one element in the subarray. And if the end index is greater than start index, it would mean that it is an invalid condition, invalid state. So when is the start index and end index of any array same? When we have only one element, right? If we have only one element, we will have only one index, that is index 0. So that is the condition that will stop the recursion, and that's why we have to make this check. Now once this check is done, if this is true, if the start index is less than the end index, the very first step is to create an integer called int p, which is going to be the partition index, and we will say partition. So partition function is called, and inside this also we are passing the same int array. So int arr, so I've named it as arr, and we are passing the same start index and we are passing the same end index. So of course we have to create this separately, so we cannot give the data type over here. We have to simply pass these variables that are created over here. These are the arguments and we have to pass them as it is, because we are giving a function call. This partition function has to be created separately, and this partition function is gonna return an integer which is going to be the index position for the next partition, right? Because if you see step 2 and 3 in the algorithm, in the quicksort function, we have to call quicksort recursively 2 times for the left partition and for the right partition. And the way we do this is we use this p point as the partition index. So what we do at the next step is we say quicksort. This time we pass the same array, obviously. The start index is going to be the same because now we are calling quicksort for the left partition. So end index this time is gonna be p minus 1. Similarly, for the right partition, the start index is gonna be p plus 1 and end index is gonna be as it is, which is e. Okay, so this is recursive quicksort call for left partition. This is recursive quicksort call for right partition. So this is it, this is the only simple thing that you have to do for the quicksort function. But the real crux or the real activities or the real code happens inside the partition function. Because this is where you get the partition index, that is this partition function returns the point where you have to do the partitioning. and it also does the sorting, that is the in-place sorting. We've seen how in-place sorting works in the working of quicksort in part 1 in detail, but now let's actually go ahead and start with writing the partition function. Now we know that this partition function returns an integer value. The integer value is the index position where the partition should happen, which is stored in this variable. So when you create the function, you have to say int partition. Of course, it is going to take an integer array. It is going to take start index and it is going to take end index. Now do note that you have to create this function on the top at the very beginning before quicksort, because if you create this function over here, what will happen is this quicksort will be called first, and when it will be called, it will look for partition, but partition is gonna be created over here, that is after quicksort. So it will throw up an error saying that they did not find this partition function. So whichever function is called first in the user defined functions has to come on the top. Okay, so when the int main will start executing, it is below the quicksort function, right? This is our user defined function. All the user defined functions, if kept above the int main, it will not throw up an error. Otherwise you'll have to do the forward declaration, because the compilation happens from top to bottom, right? So if quicksort and partition function were below int main while compiling from top to bottom, this line, this 40th line, will give us an error if quicksort function was declared below without the forward declaration. Now if you want more details, I'll drop some link in the video description to let you know what is forward declaration. But anyways, let's create the partition function. Now the very first thing in the partition function is to select one element and call it as pivot. Now depending upon how you select the element, quicksort can be divided or classified into different versions or different modes. According to our algorithm and according to what we've set in part 1, we are gonna select the last element always and set it as pivot. You can also go ahead and select the first element. You can also go and select any random element or the median element, and that's how you can implement quicksort in different modes or different ways. But our code, our setting is such that we are gonna select the last element and select it as the pivot element. So I'm gonna create an integer named pivot. We're gonna say ARR of E, and that's because E is the last index that is passed in this function. So S is the start index, E is the end index. So ARR of E would be the end element, and that would be selected as the pivot. One more integer named P index has to be set, which is gonna keep a track of the elements in the array that are smaller, and it will be incremented every time a smaller element is swapped to the left. So the whole idea about quicksort sorting algorithm is to select a pivot element. Okay, so once you have a pivot element, you compare all the other elements with that pivot element, and whichever element is smaller than the pivot, you shift it to the leftmost side of the array. And once you compare all the elements, you bring that pivot element to the position in a way that all the leftmost element are smaller than that pivot element. Okay, and that is done using this p index variable, which will keep a track of where you have to bring the pivot element at the end. So you'll understand that as we move ahead. So p index will start from the start index. So start index is given by s. So that's the second step. Now we use a for loop, and the for loop is used to do the comparison. So let's say we've selected the pivot, which is the last element. So all the other elements are supposed to be compared with that element, right? So that's where we are going to use the for loop. I'm going to say int I equals to start index. I is less than e. Okay, you can also say I is less than equal to e minus 1, or you can say I is less than e. It is pretty much the same. And the reason we have to say less than e is because if there are 5 elements in the array and the last element is selected as pivot, we only want to run from 0 to 3. That is, the first 4 elements are supposed to be compared with the last element. So you don't want to run through all the elements because the last element is the pivot. So pivot cannot be compared by itself. We have to compare all the other elements with the pivot element. Okay. Hence it is I less than e, and we have to say I plus plus. So in the for loop, we have to make that comparison. We have to say if ARR of I is less than the pivot value, then according to the algorithm, we have to do the swapping of ARR of I and ARR of p index element. Now in the algorithm, it is given by one line, but obviously swapping will require some line of code. And the basic swapping technique is to create a temporary variable. So I'm going to say int temp equals to ARR of I, ARR of I equals to ARR of P index, and then ARR of P index equals to temp. Now this is basic swapping technique. I hope you know this. And then the second step in the if block is to increment P index. So this will now move forward in the array for further comparisons and swapping. Okay. So basically this for loop is done, and this for loop, as I mentioned, will compare all the other elements with the last element which is selected as pivot. Whichever element is smaller than the pivot will be swapped to the left, and that index will be noted down. So if two elements are smaller than the pivot, the P index value will become 2. And when you come outside the for loop, we will do one more swapping, which will take that pivot element and bring it to that P index position, which is now become 2. So again, we can use the same concept of temporary variable to do the swapping. So I'm going to say int temp equals to ARR of E, because the end element is the pivot element. Then we will say ARR of E is equal to ARR of P index, and now we will say ARR of P index equals to temp. Simple enough. This is done. But one last step that is required is to return this P index. So after this entire partition function completes its execution till this point, what has happened is the pivot element will come in the array into such a position where all the elements to the left of that pivot or left of that element will be smaller, and all the elements to the right will be greater. So that index position is basically where we want to do the partition, right? So that's where we want to do the partition, and we want to apply quick sort on the left of that and on the right of that. So we need that index point, and that is where this P index is keeping a track of that particular index. And hence we are going to return that from this partition function, which will again be stored in this P variable, and then again quicksort will be called on the left and right sub arrays of that very same array, and hence we need to return this P index. Okay, so this is pretty much it. We've pretty much created both quicksort and partition functions. I hope this runs in the first go. Let's actually try to save this and let's execute this. This is where the function is gonna be called. I have uncommented it. Let's go to execute, compile and run. Okay, so yeah, we're getting an error because without error nothing works in the first go. Okay, yeah, if you see, I have missed out the brackets over here, square brackets of the array. Whenever you're creating a function which takes an array, in the arguments obviously you have to specify these square brackets to denote that it is an array variable and not a simple variable. Okay, also do note that arrays are always passed by address and not by value. And if you don't know what is passed by address, passed by value, passed by reference in C++, do check out that video where I explain it very clearly in the C++ playlist. I will link that video. In fact, I'll link the entire C++ playlist if you just want to view it. But those three concepts are important to understand the difference in. And I think everything should work now. Let's go to execute, compile and run. And yeah, things are working fine. So it's saying enter the size of the array. Let's enter 5. Enter 5 integers. Let's say 5, 4, 6, 2, 8. This is not in any particular order. If I hit enter, there you go. Before sorting 5, 4, 6, 2, 8. After sorting 2, 4, 5, 6, 8. Everything is pretty much sorted in ascending order, which means our quick sort algorithm is working fine. Let's compile and run it one more time. And let's enter, 7 elements. This time 4, 5, 3, 2, 6, 8. How many elements have we entered? 1, 2, 3, 4, 5, 6. Let's enter 34. Let's hit enter. So we have 2, 3, 4, 5, 6, 8, 34. Everything is sorted perfectly. So before sorting and after sorting, this means our program is working fine and quicksort is implemented successfully. Okay, so this was the code, that is the practical side, that is the implementation of quicksort sorting algorithm. I did not explain in depth because that is covered in part 1. So this is just the implementation part. Obviously, I'm going to be sharing the details about the theory, about the working of quicksort as well as this code on our official page. So do check that out on simplesnippets.tech, link in the video description. And that's it for this video, guys. If you like this video, please give it a thumbs up. Do share it with your friends. There are many more tutorials on data structures and algorithms coming up. So make sure you subscribe if you're new on this channel. And I'll see you guys in the next video. Peace.